Well, so from now I will make the video technology by Pikachu official only English or translate it as a translation. So want to make a video global not with me. Today have people hacking and the programming basis so I can programming basis plus and hacking because programming is very important to make everything in software industry. And after I make the video, then I will go to the next step to connect and check the cyber security. Okay, before you look at the site activity.
Hey everybody, it's Brian. Welcome to our 14th C# tutorial. Today we're going to discuss inheritance. So let's just go ahead and make
You will see the video and we will practice step by step.
a few classes here. Let's say add class, and we're going to say mammal. So we have a mammal class, and then let's just add another class here. Let me shrink this down so you can see me actually typing these out. We'll say feline, and then let's add another class here, and let's just call this lion. So we have a mammal, a feline, and a lion. Let's just kind of close these, and let's just focus on the mammal class. Let's say public, and we'll say bull for bowling. Remember, bowling is simply a true false on off. Has backbone. And public bull has hair, because all mammals have a backbone and they have hair.
Stop here and I will
So that is our mammal class. And oftentimes you'll see me put in the access modifier for everything, just so that it's crystal clear what I'm doing here. So let's close mammal, and let's actually open up feline now. In our feline class, what we're going to do here is we're going to say public bull has claws. Now, before we get too deep in this, let's actually jump into our program here. Let's just say feline and C feline equal new feline. You notice how feline only has claws. Well, feline's also a mammal, so we want to do what's called inheritance, meaning we want to inherit the properties of another class. And this may sound confusing, and if you've got books on C# or other languages, they make it sound like you're just building a bomb out of spare parts, like an episode of MacGyver, if any of you are old enough to remember that. Inheritance is not hard, and I wish people would not make it hard. Really? Just do space, colon, and then the name of the class you want to inherit. Feline mammal. You have just inherited that class. Now what does that mean? When you type C feline, you now have all the properties of the feline class, has claws, plus the mammal class, has backbone, has hair. So really what you're doing here is you're taking two classes and kind of adding them together. You have your feline class. Let's kind of go back here and review. Notice how it has claws. You have your mammal class, which has backbone and has hair, and you're combining them by saying feline inherits mammal. So you're saying take the properties of the mammal and add them to the feline class. Now, why would you need multiple inheritance? Why can't you just add those properties into the feline? Well, let's say some genetic evolution happens and mammals change. Well, dogs are also mammals, aren't they? So let's just go at class, and let's say dog. And we're going to inherit
but my computer is very full as so one two three in on the computer sit right and you see on this not that I will be symbol choosing the S symbol you at the video the second symbol in the symbol that's visible just on system.
the mammal class. So now dogs also have backbones and hair. But they, unlike felines, do not have claws. Well, yeah, technically dogs do have claws, just not the way cats do. So what you could do with dogs is just say public bull can bark. Now, my daughter will argue that our cat barks, but our cat is just really weird. It's like the exorcist cat, I swear. See dog. Oops, let's make that lowercase. So now you have C feline, which has backbone, has claws, has hair. And then you have C dog, which can bark, but also has backbone and hair. That's why you'd use multiple inheritance. When you want multiple things, I'm sorry, not multiple inheritance, when you want to use inheritance, when you want multiple classes to inherit the properties of your class. So as you see, we have our mammal class, which is very nice and self-contained, and we can put all the properties of a mammal. They breathe, they're warm-blooded, they have hair, etc., 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 and then any other class can inherit those properties. Now, one catch or gotcha, if you will, is that some languages have what's called multiple inheritance. C# does not. What is multiple inheritance? Multiple inheritance would be if you wanted to make a dog cat, where you could say, you know, dog. And you notice how it gives you a little squiggly thing and it says, you know, can't do that. What you're trying to do here is you're trying to inherit a mammal and a dog. You cannot do that in .NET. There's no such thing as multiple inheritance. So that would be like taking a toaster or a refrigerator and an airplane and all smushing them together. Now, to get around that, what you can do is called inheritance chaining. Inheritance chaining says, let's take our lion class here, and let's inherit feline. So now the lion inherits feline, the feline inherits mammal. So you have all those properties. Let's actually close dog out. I'm not a big dog fanatic here. So let's put these in order. Lion inherits feline, feline inherits mammal. That's called inheritance chaining. So if we make a lion class, you can see how it has claws from the feline class, and it also has a backbone and hair from the mammal class. But because it's in its own class, lion, we can actually go in and add our own things. So, like, let's just say public void roar. Because, well, lions roar. So now we have a function. Let's go back in here. And I'm wondering if the video is probably chopping it off. Let's see if I can scroll down a little bit here. There we go. There's our roar. So as you can see, we have our lion.roar. And if you highlight something, it says mammal.hashair. It's because it's telling you exactly where it's getting it from. Feline.hasclaws. So that's inheritance and inheritance chaining. Very simple, very easy to work with, and a very, very powerful feature. You will be using that a lot
Just
in
a
your
quick
programs.
video and I will have on this.
Some fallbacks to inheritance are very simple. If something down the line, let's say you make this lion class, which inherits feline, which inherits mammal, and somebody goes in and changes this mammal class. They say, mammals don't have hair. Well, if your lion class is depending on that value or that
Okay,
variable
let me
or
go
whatever it
on
is, you
this
just
one.
broke everything up the
Okay,
food chain here. So felines will start crashing, mammals will start crashing, etc., etc. So you want to make sure that when you allow inheritance in your classes, that you are very conscious not to change things that are going to break other classes that are inheriting you. And there's certain access modifiers and tricks you can use to keep classes from inheriting you. But we won't discuss those just yet. We're not there just yet. Anyways, this is Brian. Thank you for watching. I hope you found this tutorial educational and entertaining. Hey everybody, it's Brian. Welcome to our 14th C# tutorial. Today we're going to discuss inheritance. So let's just go ahead and make a few classes here. Let's say add class. And
Okay. And we will jump to the next one.
hey everybody, this is Brian, and this is the 15th C# tutorial. Let's make a new console application, and let's make a new class. And let's just call this class, I'm at a loss of what to call this. Let's call it Wizard, just because I'm out of names. So we have our Wizard class here, and what we're going to discuss today are getters and setters. Now, if you're used to other languages, you've seen things like this. Public int get age, and then you want a private, meaning it's only used inside this class. We'll call it mage. So you want to get the age, so we'll say return mage. And then if you want to set the age, you would say something like public void set age, and then let's do int and age. Well, this seems like a lot of typing, isn't it? I think it is. Mage, probably help if we had an access type here. And as you can see, it gets kind of clunky and error prone, and there we go, mage equal nage. And then you can do whatever you want within these things. Well, Microsoft added what's called the get and set function. So what we're going to do here is we're going to make a property. So we're going to say public int age, and then brackets. Now, you notice how we didn't put these parentheses at the end, because this is not a function, this is a property. Then you're going to say get, and notice how it has the get word in there, a code block, and then set, and a code block. That does pretty much the same thing. Now you notice how get's kind of complaining and saying not all code paths return a value, because what it's expecting is this, return mage. And then you can say set, we'll say mage equal value. Well, where's value coming from? Value is a virtual variable, if there is such a thing, that basically the Microsoft.NET framework is throwing in. So whenever you want to set the property, the value passed to it is literally value. So this right here takes place of these two functions. Now, why would you use a property? Well, property, very simple, because it acts like a variable. Let's say gets or sets the age. There we go. And then let's actually create our wizard here. Boy, how many times have you...
It's quite different another programming language okay, and very okay. That's good. We would only for this but better.
Said that in life. Let's create a wizard. and we'll say cwizard.age. Now you notice how we have the get and set, but we don't need them because we can just say age equals, and we'll say 12 because, well, he's kind of a childish wizard. Let's do a console read. And let's do a console.write right line, and we'll say cwizard.age. And let's actually go back in here. Let's delete this stuff out because we really don't need it. So let's review really quickly. We have a property, see public and age, and in our property we can get or set. Now get returns the value, and you say return mage, and you can do, because this is essentially a code block, a function, you can do any sort of computation you want in here. Same thing with set. Set's a code block. You can do anything you want in here. But the purpose of get and set is get will return a value and set will set the value. So let's actually save and run this. Sure enough, it says 12. So what's a common usage of a property? Well, let's say we want a read-only property. So let's just say public int, and we'll say read-only age. Don't get thrown by the name. We could name this anything we want. And let's just copy this, paste that. Now you notice how there's no set block. There's just a get. And that's because, well, it's read-only. Say, if we say read-only age equals 22, and we try to run that, it says build errors. What's the problem here? It says cannot be assigned to, it is read-only. That is how you protect your internal variables. Now, don't get thrown by the read-only age. We could very easily just call this bunny slippers if we wanted to. I mean, you can call it anything you want. It's a property. But in practice, you know, instead of calling something bunny slippers, you should give it a descriptive name, such as age. Notice how it's highlighting it because it's saying you cannot set, you can only get. Now, when you set something, you're using the equal sign. Age equals 12. So that's calling the set portion. When you get it, you just say wizard.age. So you're getting it. In other words, age is going to return, set is going to set it. Very simple. I know it sounds a little confusing, but really all you need to understand is that you are making a property. That property is exposed to the outside world because this variable, we call this very fragile. We don't want this exposed to the outside world because, you know, just raw chaos could happen. For example, we could say if, oh, not here, sorry, that's in the get. If value is greater than 100, well, nobody lives past 100, right? Wrong answer, I know, some people do, but actually, let's say if it's past 200, because nobody lives to be 200 old, then we'll say mh equals 200. Say that's the upper limit. Else, we will just set the value. So this is the power of a property. This is the level of complexity you can really get is just astounding. I mean, you could actually just pass this off to another class or a function and do some huge mathematical algorithm. So what we're doing is saying get just simply returns the age. Set, if the value they're trying to set is over 200, we're going to say age is 200 because that's the maximum we're going to allow. Else, we'll just set the value. So let's actually try to do this. Let's say 300, and let's see what happens here. Run this, and sure enough, the maximum age returned is 200. So as you can see, properties are very simple yet very powerful, and they're a way of protecting your internal variables inside your class. Because, well, if you just let users run amok, you get weird things like, you know, Microsoft Corporation. Anyways, this is Brian. Thank you for watching. I hope you found this educational and entertaining, and keep up on the feedback. And one thing I should probably mention before I go is if you are watching these tutorials, you can go out to my website, www.voidrealms.com, V-O-I-D realms.com,
Yeah.
and you notice the word void that we've been talking about. I mean, yeah, my website returns nothing. Anyways, go to tutorials and then C#, and I've been uploading all these, including the source code. So like you can just go out here and you can just download the source code for each tutorial and watch the video while you're out there. No, there's no subscription fees or anything like that. I do ask for donations. If, however,
Thank you for the kind visit. Many
hey
will
everybody, this is
because
Brian, and
since
welcome to the
you
16th C# tutorial.
yes.
Today we're going to be discussing interfaces. I understand interfaces sound kind of big and spooky, but trust me, they're pretty easy. So let's just say add class, and we're going to make a new class, and we're just going to leave it as class 1. And now we want to add a new item and choose interface. Now on the interface, let's just leave it as interface 1, just the default for now. And let's just say void do stuff. Oops, and let's move this down here. Now, you notice how that looks like a function, but we're not actually implementing it. We don't have the brackets in here. Well, the reason why is because an interface is simply a contract. It's saying if you're going to implement this interface, you will have the things inside of it. Do stuff, and then we will just say, and you can have multiple things in here. We'll say do stuff again. And these are just function names. And let's add a new item. Let's add another interface. Leave it as interface 2. I'm going to say void do more stuff. And you can add pretty much, as many things as you want in here. Now, remember, an interface is not a class. An interface is different in the fact that you don't actually implement anything. You just create an outline of what you want it to do, saying if you're going to have interface 1, it will have do stuff and do stuff again. What does this mean? Well, here's our class 1, and you know about inheritance. Well, if you want to implement an interface, you would say interface. You notice how there's interface 1 and 2. Interface 1, and you can right click and implement interface, and then implement interface explicitly. Now, if you implement interface, it just says add these items. So let's delete these, right click again, and do it explicitly. And it says interface 1 dot do stuff. Now, the differences between those two is a little obscure, but really all you need to understand at this point is that an interface is a contract, and there are multiple ways of having that contract. Because if your class has interface 1, it is, in effect, interface 1. I know that sounds confusing, but really at this point, just implement the interface, so it's a part of your class. Now, one thing you can do with interfaces you cannot do with inheritance is you can have multiple interfaces. Just put a comma and then say interface 2. And then right click and implement interface. See, there's do more stuff. That's from interface 2. Now you see these throw not implemented exemptions. Throw means it's going to create an error, and then it's going to create a not implemented exemption class. So it really just means if you try to call that, you haven't implemented it, it's going to crash your program. It does that to get your attention. So that is one way you would get around the multiple inheritance block that C# does not have. You use interfaces or contracts. Now, if we go to run this, let's actually say class 1, C class equal new class 1. And you see how we have all these properties in, or all these functions in here. Let's actually try to call one of these. I just want to show you what this exemption here does. And wait for it. Dramatic explosion. There we go. Throw new not implemented. It says this method or operation is not implemented. It's just their way of saying, hey, you got to fill this in. So let's click that little stop button. Now, what happens, let's just get rid of that so we don't crash our program again, if you don't implement an interface fully. Like, let's get rid of do stuff and do stuff again. So we're missing out everything in interface 1, even though we've said we're going to have interface. We've agreed to this contract. What do you think is going to happen when we go to run this program? We're just creating an instance of this class. Well, it says there were build errors. And it says do stuff again, not implemented. Do stuff, not implemented. So that is what an interface does. It says if you're going to implement an interface, you are agreeing, you are promising beyond a shadow of a doubt you will implement that interface. This would be very good for, say, a plugin system. Let's say you want to make any sort of application that has plugins. For example, Firefox web browser has plugins. It has an interface you have to follow that guarantees that every plugin is going to have functions that can be called. Don't get too caught up in the semantics of interfaces. At this point, I just want you to understand that interfaces exist and that you can use them, because we will use them in real-world programming. And interfaces also allow you to implement multiple interfaces, so you can get around the multiple inheritance problem. The problem with that, though, is that you have to create the code every single time, because an interface, you cannot implement it, you can only declare it. Whew, that's a mouthful. Well, this is Brian. Thank you for watching. I hope you found that educational and Hey everybody, this is Brian. Welcome to the 16th C# tutorial. Today we're going to be discussing interfaces. I understand interfaces sound kind of big and spooky, but trust me, they're pretty easy. So let's just say add class, and we're going to make a new class, and we're just going to leave it as class 1. And now we want to add a new item and choose interface. Now on the interface, let's just leave it as interface 1, just the default for now. And let's just say void do. Hey everybody, this is Brian, and welcome to the 17th C# tutorial. Today we're going to be discussing error handling because, well, let's face it, bad things happen in programs. So to do this, let's just say int, and we'll say x equal 1 and int y equals 0. And we're going to create what's called a division by 0 error, meaning you cannot divide something by 0, so it's going to crash our program. And we're going to say int, we'll say, actually let's say double z equal x divided by y. Now, everything looks fine. There's no little red squigglies, no warnings, but when we go to run this, well, bad things happen. Attempted to divide by 0. That means your program just crashed and died. And you see in the locals window over here, you have argument 0, string 0, x1, y0, z 0.0. And then it's telling you, the call stack, something bad happened on line 15, etc., etc. So all you can really do at this point is just close your program and figure out how to handle this. So now we have to figure out how to avoid this situation. So what you want to do is select your code, and you can right click and surround with and just choose try. And that'll add the code for you. So it says try, code block, catch, exemption, code block, and you got to do something here. So let's give the exemption a name. We're just going to call it E. We could actually just call this error if you want to. Make it a little clearer what it does. And let's just say console write line, and let's say error.message. So let's discuss this a little bit. Let's figure out what's going on here. What we're saying is try. That is a try block, meaning this code's going to try to execute. If something bad happens while it's executing, it's going to catch that exemption. An exemption is an error. So we're going to say the exemption class, we're giving it a name of error, and then we need to do something when we catch that error. Console.writeline error.message. And error has a bunch of properties. As you can see, the exemption class is actually pretty big. You can get the inner exemption, the stack trace, I mean, you name it, you can do it. But for this, let's just stick with message. We just want to know what happened. So let's run this again. Whoops, we forgot to console.read. And of course it says attempted to divide by 0. So as you can see, you can try some code, you can catch the error, and let's say 55. Now there was no error, so the program opens and closes instantly because it said try, it ran this code, and it succeeded, meaning the catch block was never called. You can add another block called finally. Whoops. And what finally does is finally always runs. Meaning, it doesn't matter if try runs or catch runs, finally will always run. So in this case, we run it and we get just a, if I can grab it, a black window because we haven't printed anything out. So let's go ahead and go console, write line, and let's just print out the value of z. So what we're going to do here is we're just going to print out the value of z, or we're going to print out the error message, and we're always going to read. So the value is 0, and then we know what these do. So what happens if you want to intentionally throw an error and you don't want to do some funky division by 0 thing? For example, let's just say you want to do a hello world. After hello world, you want to say goodbye. But you intentionally want to raise an error. You want to know that something happened and you want an error condition to exist. Well, you use what's called the throw keyword. Kind of like when you're mad, you throw something against the wall. Well, don't do that, especially in my house. Throw new exemption, and we're just going to give it a name here, and we're just going to say goodbye cruel world. Now you notice how console down here is suddenly highlighting green. It says unreachable code detected. That's because when you throw, it's instantly going to go down into this catch condition. So you can actually just get rid of that because you know as soon as it says throw, it's just going to jump down to catch. Now we can leave that in there and run this and see exactly what happens. It says hello world, goodbye, misspelled of course, cruel world. Let's fix that misspelling here. So this never runs. It never runs because we threw an exemption, and the exemption automatically throws us down to catch. Now if we don't have catch in here, let's actually delete that, and let's try running this. You guessed it, crashes our program again. Goodbye, cruel world. And it generates our error. So that's how error catching and error handling work in .NET. Pretty simple, pretty powerful. You can generate your own error messages. That's typically if you are creating your own class and you want to create an exemption condition, meaning like age would be a good example. Somebody enters 3,000 for an age. Well, obviously they're being a punk, and you want to say, hey, can't do that. So you throw a new exemption and saying your age must be between 1 and, say, 99 or whatever. That's all for this tutorial. Hope you found this educational and entertaining, and thank you. Hey everybody, this is Brian, and welcome to the 17th C# tutorial. Today we're going to be discussing error handling because, well, let's face it, bad things. Hey everybody, it's Brian, and welcome to the, oh man, what are we up to? The 18th C# tutorial. And we're just going to make a new project, and we're going to make a console application. Today we're going to kick things up a notch. I said we're going to ramp these tutorials up rather quickly, and I was not joking. We're not going to go over the normal, what's a variable, what's this, what's that, because, well, to be honest, most of you are smart enough to understand this stuff anyways. So what we're going to discuss today is called file input output. So first thing we need to do is use a namespace. Notice how we've been talking about namespace, but we haven't actually used one. So type using, and you notice a little IntelliSense popped up. Type system, and then we want, and you notice all these little beautiful things that pop up. These are all namespaces, and while we probably won't cover all of these because the .NET framework is just massive, we're going to cover a good majority of these. And what we want is I/O, which stands for simple input output. Now in the system I/O namespace, let's just copy this. I want to show you something. If you just type system I/O dot, you can actually just navigate the namespace and see what's in there. You see there's a lot of stuff in here. Well, what the I/O namespace does is, well, you guessed it, input output. This is how you write to a file, read a listing of directories, things of that nature. So what we're going to do today is we're just very simply going to read and write a file. So let's just do static void, we'll say write file. And we're just going to make a function to write the file, and we're going to make another function to read the file. And then we're just going to call these, in turn, and we'll just make a variable. Now, one thing I want to discuss about strings is if you try to do something like this, let's just say etest my doc.txt, you notice how it just starts freaking out. Well, the problem is these backslashes. That's an escape character. So what you need to do is put an @ symbol in front. What that does is says this is a string literal, meaning this is all one string, not this is a string, this is a string, this is a string, because it treats that as an escape character. Escape characters add things like hard returns, tabs, things of that nature. So if you see that @ symbol in front of a string, that's really all it's doing. It's saying ignore that slash. And then we're going to say write file, file name, and then we want to read file, file name. Now we haven't actually done anything yet. We're just calling some functions here. So we've got our string, which is our file name, and we're going to write file, which is going to jump up here, and then we're going to write the file. So what we need to do here, and there's a couple ways we can do this, and we're going to do it the easy way this time because I want to kind of slowly ease you into this. I'm just going to say file, write all text, and you notice how it says string path, string contents. So we will just say file name, and we're just going to simply say hello world. Now we want to read the contents. So we want to say file, read all text, and you notice how this returns a string. We could also say read all lines, which returns an array of strings. So which one do you want to do? Well, it really doesn't matter. Read all text will just return all of the text. Read all line will return every single line. For this tutorial, we're just going to say read all text. We're going to say console, write line, and we want to say file, read all text, and then we need to get a path, and which is just, you guessed it, file name. So that, in a nutshell, is the simplest way of reading and writing a file. So let's run this. Uh-oh, build errors. What did we do wrong here? Oh yes, simply forgot. That's one thing I do love about .NET is the debugging is first class. I have yet to find anything that even comes close. Yes, we forgot to do our console read. And there we go. We have written our file and we read it back out into the console. Now that is extremely simple input-output. The next tutorial we're going to get a little more complex, but that's it for this one. This is Brian. Thank you for watching. I hope you found this educational and entertaining. Hey everybody, it's Brian, and welcome to the, oh man, what are we up to? The 18th C# tutorial. And we're just going to make a new project, and we're going to make a console. Hey everybody, it's Brian. Welcome to the 19th C# tutorial. We're just going to do a little more advanced file I/O. So let's just do using system.io. And I'm going to kind of whip through this because, well, we've already covered this. So I'll just say static. Now, if some of you are wondering, why are we saying static? Well, because our main is static. You can't call a non-static from a static. Say write file. If you don't know what static is, I suggest you watch the other tutorials. Basically, static just means you can have only one instance of it. Alright, so we got our write file, and now we want to do read file. And then, of course, we're just going to call these one at a time. Forgot to make our variable here. Oops, put this in the usual location. And you don't have to name it a text file. I mean, it can really be named anything. And I'm just whipping through the basics here. Of course, we want our console.read. That way our console window stays open. Now we can get to the nitty-gritty here. And let's just unpin that. We want to write our file. So really what we need to do is make what's called a file stream. Think of a stream much like a stream. That's why it's called a stream. It's like a river or a stream. It's just data that constantly flows. So we're going to say file stream, and we'll just call this fs equal new file stream. And notice how we got a lot of options here. Well, we're going to keep it simple. We're going to say file name, and then we need a file mode. And file mode, I don't know if you can see it in the video, but you get like append, create, blah, 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 blah. Well, you should read the documentation for these. Append will open it and write to the end. Create will create the file. If it exists, it's overwritten. Create new will throw an error if it already exists. Open will open it. Open or create will open or create it, truncate it, just wipes the file clean and starts over. So what we're going to do here is we are going to say create. That way it is just completely overwritten every single time. And then we want a file access. And file access, I don't know if you can see it in the video, determines what you're doing here. We're saying file access read, write, or write. What do we want to write? So what we're saying is we're making a stream that we're creating. See, file mode create. And the mode is write, meaning we're only going to write. We cannot read from the stream. And it makes it much simpler, much faster because, well, you're only going to write to it. So it just keeps going and going and ignores what you've already done. I know that sounds funky, but trust me, it works and it's very good. One thing you should always do when you're writing is call flush. Flush is, well, like flushing the toilet. You flush everything down to the stream and make sure it gets written down to the disk. Some people would argue that calling close flushes it. But I found from personal experience sometimes that's not necessarily true, so I would just caution you to use flush. Now that we've got our stream, we want to do something to it. Well, we're in write mode, so if we attempt to read, it's going to throw an error. So what we do is we say fs, and you notice how we can write byte, write timeout, begin write, etc., etc. Well, we're just going to write. And what you should do is say can write, just to determine. So we'll say if fs can write, and then we'll say fs write. And notice how it wants a byte array, an offset, and a count. Well, this is the tricky part about working with streams, is that it takes byte arrays. So let's say we want to write a string down to this file stream. How do we convert a string to a byte array and vice versa? Well, let's comment that out for a minute, and let's just, well, create a byte array. We'll say byte, and we'll call this buffer equal encoding, and we'll just say ASCII get bytes. And what encoding ASCII.get bytes does, and I should back up for a minute and say, well, you can use any type of encoding. A lot of people, instead of using ASCII, will just use default, which is, you know, pretty good. Encoding determines the characters and how they're fleshed out to the disk. I like using ASCII just so I know what to expect. And we can say get bytes, and then you can convert things. For example, a string, characters, anything you want. So we're just going to say hello world. That converts this string hello world into a byte array, which we can use with a stream. Now there are easier ways of doing this, but I'm showing you the hardcore. This is how you get stuff done. Now the offset, this is the position in the byte array that we just created. So if you wanted to start at, say, the 5th position, you would count 0, 1, 2, 3, 4, 5. So it would start right there. That's the offset. We want to start at the beginning, so it's going to be 0. And then it wants to count. How many bytes total do you want to write out? Well, we want to write them all, so we're just going to say buffer.length. Pretty simple stuff. Now, why would you do it this way? Well, very simple. Sometimes you need absolute control over what's getting written to the disk and in what order and how. So you would convert everything into a byte array. A byte is the simplest, smallest logical value that you're going to have in C#. And then you write that out to the disk as raw bytes. Now, reading is actually pretty similar. We're just going to say file stream fs equal new file stream, and we want to give it a file name that we want to open. So we're just going to give it our variable here. Help if I could type. And then we want file access. We want to read. Whoops, let me back up here. I want to make this as similar to the old one as possible. We'll say file mode. And we want to do open because we want to open the file. And then a file access. And then we want to read. There we go. So what we're saying here is we're creating a new file stream from the file name. We want to open the file. We're not creating, appending, or trunking. So we want to open. And then we want to read from it. Now, if that file doesn't exist and we try to open it, it's going to throw a humongous error and say, file not found. That's why you use file mode open. So if the file doesn't exist, you can catch it with an exemption. And then we're just going to say fs.close, because you always want to close a stream or a resource when you open it. Now we actually need to read it. So I'll say fs read. And this is where you get the number of bytes you've actually read from this thing. So let's just say int bytes read equal fs read, and then we need a buffer. So you see how everything works with this byte array. I know that can be incredibly frustrating, but what we need to do here is make a buffer. So let's just say byte, call this buffer equal new byte, and we'll just give it 1K. So we're going to have a buffer of 1024 bytes, and we want to begin reading at the 0 position of the stream. and reads a block of bytes from blah blah blah. So this is the maximum number of bytes we're going to allow this to read. That way we don't have a buffer overflow. Buffer overflow, if you know anything about hacking and penetration testing, is a bad thing to have in your software. So we're just going to say buffer.length. From this, we get bytes read. So we actually have a buffer of 1024. But you can see in our file, we don't have 1024 bytes going into this file. We have like maybe, what, 10, 11, 12? So we're going to get the number of bytes read out of here. And it's going to fill in this buffer. The buffer will still be 1000, how many we've gotten. And then we'll just say console dot write line. Actually, you could just say write. And let's see. Yep, there's that. Trying to see if they've got a byte in there. No, they don't. Well, what you can do here is say console dot, and we'll just say write line. Maybe if my keyboard would quit flipping out on me. Sorry, I've got it geared towards gaming. And then we can just say encoding ASCII, and we'll say get string. That will convert the bytes into a string. And you notice how it also has an index and a count. So we'll say buffer index. This is the position of the first byte. So we want to start at the 0 position, or the first byte. And then we want to know how many bytes to actually process. Well, we want the bytes read, because we want to know exactly how many of these to do. So let's see what's wrong here. Sorry, my cat's distracting me. Quick review before we run this. When we write the file, we're creating a new file stream. Think of a stream as a highway. It goes all the way behind you farther than you can see, and it goes all the way in front of you further than you can see, and there's data all along here. That's a file stream. Now, I'm not saying it's infinite. A stream has a length. I'm just saying it can be a very, very long road. It's much simpler and easier than an array. As you can see with an array, you've got to say a number of bytes you want to put into it. Now, we create our file stream, we give it a file name, we're telling it how to create the file stream, meaning how to create the file. Then we give it an access mode where we're going to write, read, or read and write. And then we're saying if we can write, then do something. And in this case, we're just making a buffer of bytes, and we're using encoding ASCII.getBytes to turn hello world into an array of bytes. And then we're just simply writing that out to the disk, flushing the contents, and closing the stream. And then with read, we could have done the can read, and just for sanity's sake, let's just say if fs dot can read, and let's just copy and paste that in there. So same thing, we're just opening the file. We're saying open, so the file must exist or this will throw an error. And then file access read. Then we're saying if we can read, then we're going to make a buffer, make it big enough to hold the contents of the file. Then we're going to read that in. Now you may be asking, how do I know how big to make that buffer? Well, let me show you a little trick here. You can go fs.length, and that'll get the length of the file stream, or the length of the file. So we're just making a buffer big enough to hold the entire file, and then we're just going to read it in. Then we're going to take that buffer, convert it into a string using encoding ASCII getString, and throw it back out into the console. And then our program will simply just sit there and wait. So run this, and of course it says, hello world. So that is more advanced file input-output. I realize I kind of whipped through this pretty quickly, but really what you need to understand are the concepts of streams. A lot of the underlying mechanisms in .NETs use streams, so you should get very comfortable with them. A stream is just a class. You see how when you hover over it says class system io.filestream. It's just a class. It's just an object, it's a blueprint. You've worked with these before, so don't be intimidated. Anyways, I'm babbling. This is Brian. I hope you found this tutorial educational and entertaining. And I'm going to try and whip out more of these, not just C#, but also Q, C++, but uploading video right Hey everybody, this is Brian, and today we start our 20th C# tutorial, effectively what I call the good stuff. It's great to do a console application, but sometimes you need a little bit more, like a Windows application. So that's what we're going to dive into today, and we're going to spend quite a bit of time on Windows apps, and then we're potentially going to do services, and then web pages. I know a lot of you want to do web apps. So we have our simple our simple Windows application. You see it says Form 1, and there's this little window, and when you click the close button, nothing happens. Why is that? Well, this is actually your window template. You see how you can kind of scale this around and do whatever you want, but none of the actual buttons and stuff work. Why is that? Well, it's because this is a canvas that you can drag and drop tools onto. Now, if you click the Solutions Explorer, you'll see that, let me pin that up there, you've got Form 1. And that's what this is Form 1. If you expand that out, you see there is a Form1.designer and a Form1.res. The designer, if you click that, this is the actual source code behind that form, and you can see there's a lot of stuff in here that's already pre-generated for you. For example, initialize component, etc., etc. And Microsoft's done a fairly good job of, kind of commenting what this stuff does. General rule of thumb, don't modify this. And then there's this resx. Now what is that? Well, this is a resource file, something you may have covered in other languages. Basically, a resource file allows you to put resources, images, strings, things of that nature in a file. Let's close that. And let's go Tools over here, and let's pin that up. Now, you see you have this huge assortment of controls, and we're going to go over a lot of these. And I have to apologize if you hear some thumping noise. And my cat is jumping around my desk like a lunatic. Alright, so first thing we're going to do is we're going to put a button on here. You just click, drag, and drop. There's your button. You notice how it gets these little handles, and you can resize the button however you see fit. So let's just throw that kind of in the center here. You notice how it's off center? Well, you have these positionals. So you can say, we want this, let's see here, centered that way. See if I can get this right. Center horizontally, there we go. Center vertically, there we are. Makes it easier to center things. Now, to run, you just click this little Start Debugging, or you can press F5 on the keyboard. And let me move the window over here. You see, there's our beautiful window with our button that does absolutely nothing. So what we're going to do is we're going to make this button do something. I realize this is a very simple tutorial, but GUI programming may be new to some of you out there. If it's not, bear with me. We're going to ramp up these tutorials fairly quickly. Alright, so select your button. You can tell it's selected because you've got these little handles around it. And just double click it. And notice how it dumps you directly into the code view. Let's expand that. So we're in button one click. This is an event. Windows form programming is event driven, meaning this is called when the button is clicked. That's an event handler. Notice how there's an object sender. Everything in .NET says object. So they're just saying whatever the sender was. And event args. What are event args? Well, event args, or short for event arguments, is just an argument sent with the event. And you can actually expand that and create your own event args. I actually do that quite a bit in my own programming. But, like I said, this is a beginner's tutorial, so we're going to keep it very simple. All you need to understand at this point is when the user clicks that button, this event is called. And we can even say, this is called when the button is clicked. My cat is looking at me like I have just lost my mind. Go away, kitty. And what we want to do is type messagebox.show, and we're just going to say hello world. The obligatory hello world application here. And let's run this. Show our window here. Click it. Hello world. So that is our very first Windows Form application. Not a lot to it, mind you. One thing you should know in the Solution Explorer here, let me see if I can actually find it. View, other windows, properties windows, here we go. Everything has properties, and this is the properties window. So when you click your button, you see it has a bunch of properties. And when you click your form, it has a bunch of properties. See, like the name even. So we can change the title here. See, text, form 1. Let's just call this My App. Notice how the title bar over here changed. Button 1, the text, let's just say, click me. Notice how it changed. See this little lightning bolt here? That's the events. And as you can see, the click event is linked to button 1 click. And if you just double click that, it takes you right to it. Pretty simple, pretty easy to understand. Notice how the properties for the code view are not displayed because, well, code doesn't have a property, but the designer view does. And you can switch from events to properties just by clicking the buttons. You can group them by category, and you can sort alphabetical. I understand that because this window is so small, it's probably a little cluttered. Yours will probably look much better on your screen. So that is it. Our very first GUI application in C#. And you can kind of stretch this out, modify it, and do whatever you want. Well, this is Brian. Thank you for watching. I hope you found this educational and entertaining. Hey everybody, this is Brian, and today we start our 20th C# tutorial, effectively what I call the good stuff. It's great to do a console application, but sometimes you need a little bit more, like a Windows application. So that's what we're going to dive into today, and we're going to Hey everybody, this is Brian. Welcome to the 21st C# tutorial. We're just going to make a Windows form application. And let's open up our toolbar here and make sure that it stays open by pinning it. Today we're going to discuss the button. The button doesn't seem like a big deal. You've seen a million of these things. You just drag and drop 2 buttons on here. You got button 1, button 2. So when you run this thing, you drag the application over here, you see button 1, button 2. Nothing really happens. So what is a button? Well, as you see, when you click it, something is supposed to happen. You've seen buttons before, so I'm not going to dull you with the internals of how a button works. But what you need to know is the events needed to make this thing work. And really the event you're going to use the most is click. Now, there's 2 ways of doing it. You can either select the click event and then just double click, and it'll generate the code. Let me unpin the toolbar there. And there's button 1 click. Or in the designer, you can just select the button and then double click it and it puts it in there. Pretty simple, pretty easy. Not a whole lot to really show you here with the button. Just going to do a basic message box. Oops, hello from button 1. Help if I put that inside of quotes here. And hello from button 2. Now, one handy trick I kind of want to show you is the form itself is actually a control. See, you've got form 1 selected, and then you've got properties and events. So we can actually just resize this a little bit. You see the form has a whole ton of properties. Something you should kind of explore is this properties window. Whenever you select a control, you notice how it flips over to that control, and then it has the properties. So we're just going to look at form 1 startup position. See how it says Windows default? You can actually say center screen or center parent or something else. So when you run this, it just runs directly in the center of your screen. Now when we click the buttons, hello from button 1, hello from button 2. Easy to use, easy to clean, easy to load. It's kind of a military term, but anyways. Exploring the button object here, you can see there's something called text. So you can say, click me. And then you have special things like alignment, overlay, things like that. Visible, you can make the button not visible. So like let's go into button 1 and we'll say button 2 dot visible equal true. So what are we doing here? I know this seems simple, but let's review. In the properties of button 2, we're saying visible equal false right here. So when we click button 1, we're saying show hello from button 1, and then button 2 visible equal true. So we're going to show that button. So let's go ahead and run this. Notice how button 2 is invisible. There's nothing there. You can click all you want, it's just not there. You click button 1, and let's move this. You notice how it's still invisible because we have this message box up. That's called a modular window, or a modeler. Is it modeler or modular? Somebody message me and let me know. I always get those confused. Basically, what it means is while this message box is up, you can't click on anything else. Notice how it's like freaking out. Now, when you hit OK, it returns back to the form. Watch. Notice how suddenly click me is there. Same thing. So, pretty simple, pretty quick tutorial. That's really all I wanted to show you was the button object. Thank you for watching. I hope you found this educational and entertaining, and give me some feedback on these. I really want to make the C# tutorials really polished and really good. As good, if not better, than my Qt tutorials because, well, C# admittedly is my favorite language, and my only regret with using it is that Visual Studio doesn't run in Linux. But don't tell Microsoft that. Alright, thanks for watching. Hey everybody.
Okay, so I will look into the people who do that player. Some error about so dialog and then this media that's not to run here. File first. Yeah, yeah, what this? Yeah, yeah. File, yeah, yeah, reduce this, but you know the next year, only video is step by step. To check all drivers, I think that's something for everything. When we hop, we have player doing that. When we check, we hop, we have player, we check it, and we do it. Um, this control the software to save.
Hey everybody, this is Brian. Welcome to the 22nd C# tutorial. Once again, we're going to make a Windows Form application. And let's move this down today. We've already learned the button object, so let's just throw a button on there. And what we're going to learn next is called the text box. Now you notice how it has these in the toolbox here. Sorry, let's back up. It says all Windows Forms. You can collapse these little panes here. So you can get into various things. What we're going to really be discussing first are in the common controls. They're called common controls because they're pretty common to pretty much all Windows applications. Let's actually throw a label on here. And let's throw a text button to make a Windows Form application. C# tutorial. Welcome to the 22nd C# tutorial. Once again, we're going to make a Windows Form application. And let's move this down today. We've already learned the button object, so let's just throw a button on there. And what we're going to learn next is called the text box. Now you notice how it has these in the toolbox here. Sorry, let's back up. It says all Windows Forms. You can collapse these little panes here. So you can get into various things. What we're going to really be discussing first are in the common controls. They're called common controls because they're pretty common to pretty much all Windows applications. Let's actually throw a label on here. And let's throw a text box in here too. Today, really what we're going to be covering is the text box. Now, as you move controls around, you notice how you can click, drag, and select and move them around. You can select others, and as you move, you see that blue line that just appeared. Notice how it turns pink? That pink means it's aligned. So if you're not sure about your alignment, you're moving this button around, you're like, I really want to with that text box, you can see how it aligns it. And when in doubt, you can always just select a bunch of controls and then use up here the increase spacing, decrease, remove horizontal, make vertical spacing equal, etc., etc., etc. Just play around with those a little bit, see how you like them. Now, if you try to center vertically, that's what it does, and that's what it does. So vertical, horizontal. Pretty simple. I'm just going to move these back up here, and let's resize our form a little bit. Now, let's actually just take this button. We're going to copy and paste that on there. Yes, you can copy and paste objects. We're just going to play around a little bit here. Let's just make something really goofy. Oops, if you're wondering why it changed to 4, I got my gaming mouse hooked up. Sorry about that. We'll say set time and get time. Time is, I'm just kind of whipping through here. If you're wondering what a label is just quite literally a control that displays text. You can do other neat things with a label, but it's beyond the scope of this tutorial. Really what we want to do with this is just display the text time is. And then we've got our text box. And there's a thing called Windows Design Patterns. You notice how it looks much better if it's like that. So when you're designing an application, try to adhere to the Windows design patterns. In other words, don't put like a button on top of your text box or put a button above it or something like that. Look at applications you've used and you've loved and try to design them. Don't blatantly rip them off, copy them, just design them in a similar pattern. You notice how there's menus, toolbars, and there's status bar, things like that. It's called a Windows design pattern. Anyways, getting way ahead of myself here. Let's just select time the form, and we'll just say time demo. That's in the text property of form 1 in case you're wondering. Notice how it changes the title. And we're just going to play around with this form just for a few minutes here. And we're going to say minimize box, false. Maximize box, false. You notice how they disappear here. Now when let's do the startup position, make it easy on us, center screen. Save this, run it, and there is our beautiful little form. Now you notice the min and max buttons are gone, but we can still resize the form. Let's fix that problem real quick here. Scroll up. And what we're looking for here is form border style. Instead of sizable, we want fixed single. And there's other things like fixed dialog, sizable, etc., etc., etc. Kind of play around with these. Like there's fixed 3D, fixed dialog, etc., etc. I just want fixed single just for the sake of argument here. Now when we run this, notice how you can't resize it anymore. You can still move it around. No min and max button. We change the title. Alright. Now, what we want to do is we want to change the properties of this text box. So we'll say set text, or we're set time, sorry. And we're going to say text box 1 text equal datetime now to string. We're just getting the system date time and we're setting it into the text box. So when we click set time, it's just going to put the date and time here. And we should probably actually span this out because it's going to be fairly long. And get time, we're just going to display a message box. We're going to say message box show text one, or I'm sorry, text box one dot text. And let's just set time, and there's the current system date and time. And if we press get time, it shows a message box, which is just the contents of the text box itself. I mean, this could be anything like, dear kitty, please don't bite my feet, ouch, while I am recording. Yes, the kitten has been under my desk biting my feet the whole tutorial. Dear kitty, please don't bite my feet while I'm recording. So that's how a text box works. I'm sure you've seen these before, so we're not going to spend a ton of time on here. Hold on a second. Get out of here, you little demon. Wow. This cat ignores me until I start recording, and then he just loves my feet. Anyways, sorry. Text box, you can enter things into it, and you can get the contents from it. Pretty simple, pretty easy. Not a very complex control, so not a very complex tutorial. Thank you for watching. I hope you found this educational. Hey everybody, this is Brian. Welcome to the 22nd C# tutorial. Hey everybody, it's Brian. Welcome to the 23rd C# tutorial. Today we're just going to make a simple Windows form application, and we're going to be discussing the checkbox. So let's just throw a checkbox and a button up there, and then we're going to set the startup position to center screen on the form. That way it just pops open where we want it to. Align our stuff a little bit. Change the text of the text box, that's the label portion of it, to enabled. Now what we're going to do is we're going to make this application very simple, very easy. When it loads, it's going to check the state of this checkbox and enable or disable the button. And when we check or uncheck the checkbox, it'll enable or disable the button. Let me show you what I mean here. F5 to run. When we check this, the button should be enabled. When we uncheck it, it'll be disabled. That's really all the checkbox does, is just true or false, yes or no. So let's double click our form, get our form load. Double click our checkbox, get the checkbox one check changed. Notice how you can just double click the control and you don't have to sit here and go into the events and muck around and figure out which one you want. So just a very quick shortcut. We're going to make a function here, private void, do checked. And we're going to say button 1 enabled equal checkbox 1 checked. There you have it. That's as hard as that is. You notice how the enabled is a boolean and the checked is a boolean. So they're both the same type, so you can just say equals. You don't have to do any sort of funky processing. Then you can just add your function in here. So when the form is loaded, it's going to call this function, and when the state of the checkbox changes, it's going to call the function again. Save your work, F5 to run. Sure enough, it's disabled, enabled, disabled. So there you have it. There's the checkbox in all of its glory. Not a long tutorial, but this isn't a very difficult control to work with, so there's not a whole lot there to discuss. This is Brian. Thank you for watching. I hope you found this educational. Hey everybody, it's Brian. Welcome to the 23rd. Hey everybody, this is Brian. Welcome to the 24th C# tutorial. Today we're going to be discussing the radio button. Let's see if I can find it here. Yes, radio button. Let's just throw a couple of these on here. And you notice how it names them radio button 1, 2, and 3. Now, what does a radio button do? Well, you notice how one's kind of dotted. It's not really a check, it's more of a dot. And when you select another one, it unchecks and checks the other one. So that's how you select an option, like what's your favorite color, red, green, blue, something like that. So let's actually set the text of these. And I want to show you what happens. Actually, let me grab a group box here. Let's expand containers, and you see a group box. Just drag and drop that out there. And I want to show you the base functionality of a group box in regards to radio buttons. Let's just Control C, select the group box, Control V, and now we've got two sets of radio buttons. Now how do I know there are two sets? They're in different containers. When you select this group box, this acts as a container, whereas the form is a container also. So let's actually set this to center screen. That way we know where it's going to show up. Run this. You notice how we have two different sets of radio buttons. So you could say, what's your favorite color? What's your secondary favorite color? Now, how do you actually get the value here? How do you know what's what? Well, let's throw a button out here and let's find out. So we're just going to say, and you notice how there's the radio buttons. Radio button 1, checked. Very simple, very easy. So you could say, okay, if-then statements. This is probably the easiest way to do it. And let's just make a string here. Say string scolor. And we'll say radio button 1 text. And that's all we're really going to do here. Now, I know some of you out there, some of you old gurus, are probably screaming, Brian, there's easier ways. This is a beginner's tutorial, guys, so let's just keep it from a beginner's level. So that's one way of doing it. Save it. And let's actually throw a message box up here. Whoops. F5 and run. So let's say my favorite color is blue. Click the button and ooh, we did a boo-boo. Scolor equal radio. Yes, radio 3.text. That's why.
Hello.
So let's try that again. Blue, and there we go. My favorite color is blue. Let's try green. Sure enough, green. So let's find a more advanced yet simpler way of doing this here. Let's throw another button out here. Button 2, double click that. Now what I want to do is make a function. We'll call this private void get color. And we want a radio button, and we'll just call this RDO button as our parameter. So what we're going to do here is we're going to say, okay, send this radio button as the parameter to this function. And we're going to encapsulate this code here. So we're going to say, if RDO button, the radio button, checked, then we're just going to pop up the message box here, just for sake of argument here. then we will just simply say get color, radio button 4, and we will just do this a couple times here. And this is a more advanced option. The most advanced option, which we won't get into today because it's beyond the scope of what we learned so far, is using what's called reflection, where you would query all the controls on the form and then see if it's a radio button, and then for each radio button do something. But this is a mid-range version of it. So let's run this, and we'll say green. Notice how this is blue, this is green. So that, in a nutshell, is the beginner's guide to the radio button. This is Brian. I hope you found this tutorial educational and entertaining, and thanks for watching.
Okay, then here I was fun. UNESCO Zara. This is starting. The secret box is here. Any what's in here? Secret box is in here. Oh my god. And yeah, Zara, Zara, I think five, 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 six, seven, eight, okay. Many cost of it. So so I think we finish this cost and copy that and what I come back to you.